and others in the space recently. So you could probably, Windows come quite a long way, especially in the last 18 months and even the last 6 months, towards having much more sophisticated approach to infrastructure as code and automating that setup and maintenance of servers. But also, so really, if you're an organization who do have Windows environments or Windows servers, this is a real contender. So I'm sure you're all using Share, Hub, Ansible, and others. But if you do have Windows in your stock, then this is something you should probably consider. Finally, also, I just want to kind of highlight, or will highlight, there is a real vibrant community, probably something that Microsoft's not been synonymous with in the past. An open source community that Seek in particular trying to give back to as well. Just before I kick on, actually, so hand up who's used PowerShell, Windows, PowerShell. Okay, good, 50%, good. Well, the other 50%, this is going to be a lot better. All right, the problem with that itself, similar to probably what you guys set up in the past. We had a manual setup of service. And manual leads to error prone, and it takes a long time. And there are subsequent problems for that. So we set ourselves really some key goals. And the mantra that we went out with was, we want someone with kind of a developer skill set. It's not DevOps, just developer skill set to be able to build any server in any environment, on any platform at any time. And also that build time in under 15 minutes. A kind of side thing to that was that it should only take less than 5 minutes of effort to do that. And that's really down from, well, weeks. Certain servers we've got have been taking even longer than that. So it's a real benefit to the organization. Also, no pets. So that mantra that's been going around for a long period of time. So we became very adept at code drift. It happens, it's quite over many years, and we want to put a stop to that. And so this was a key drive for us as well. One of the other benefits was dev machines. So just a bit of an anecdote. We've got streams here at Seek, and one of them, the candidate stream that looks after the job seeker side. So if you go to seek.com.au, it looks after that. We had a developer start recently, and it took him 2 weeks to get his dev machine up and running. So we want to drive that down to 2 hours. We've got it kind of in another area down to about a day, but we want to really drive that down to a couple of hours. All right, a bit about DSC, PowerShell DSC. So this guy, Jeffrey Snova, about in the early 2000s, him and a bunch of other guys, system administrators working for Microsoft, they had a Linux background, Unix background. And they came out with this Monad manifesto, and that laid out a number of different points of what they thought could be a great shell on top of the .NET platform. And the outcome of that was PowerShell. And so that's, and the 2006 saw the first release PowerShell 1.0, and that was really used to drive things on Windows 2003. One of the key points in that manifesto was about managing and maintaining devices, and DSC, or desired state configuration, was the outcome of that. And that's been around since now about 2012. But what we've seen from Microsoft and others, especially in the last few years, and especially as the next version of DSC has come out, and that came out with PowerShell 5, and that came with a slew of different innovations, especially around Windows Management Foundation Framework 5. And you've got a lot of these kind of, if I can do this, so a lot of these extra facilities and features that came with that technology. But also, very unlike Microsoft, this is kind of a window into a new world. Pesta is a BDD framework that we use quite a lot, and that's now pre-installed on Windows 10. So if you got Windows 10, you've got Pesta. Windows 2016, you'll have Pesta. You'll have PowerShell 5. You'll have WNF 5. All these just come pre-installed on the baseline Windows box. Something we're looking at the moment, Azure Automation Server. So that's something that analogous to your Chef server, so it's a big step up from the what we've got at the moment, which is the full server, and we are looking at the public preview of that, and that's been out for just a couple of months. It's just an indication. Last couple of years, last 18 months and last 6 months, it's been a real drive of innovation. And this is another thing also, just speaking to the community, quite a vibrant community. There's especially gone to PowerShellGallery.org. As of today, they've got 278 resources, and a resource is something that will help you manage an asset. So SQL Server, MySQL, MSN queuing, or anything like that. And also, Microsoft are coming out with this, they call them waves. So every X number of months, they'll have a new wave of these resources. The latest wave is wave 10, and there's about 180 resources available just to download from GitHub. And Seek ourselves, we're also contributing towards those resources as well. So why did we pick Windows DSC? Unsurprisingly, we've got quite a lot of Windows infrastructure, so it naturally kind of fell out. We've got guys who are very familiar with Windows PowerShell, and so the learning curve was quite shallow there as well. Plus, also, we had to be certain that this was going to be a reliable and scalable. And given that we're looking at the architecture is actually very simple, and the way it's set up, but overlay that with very powerful framework around PowerShell, we felt quite confident that we could scale out to the thousands of servers that we need to manage here at Seek. But saying that, we did look at Chef. In fact, when we went into this project, Chef was going to be the #1 thing. But what we kind of realized was that the facilities that Chef provided for interacting with PowerShell DSC is pretty awkward, it's pretty clunky. And so we decided against that. So key takeout really is, if you're on a Windows platform, PowerShell DSC is probably the best solution for you. But what Angel will now do is take you through a bit more information about that last point, and also a deep dive into DSC.
Thank you, James. Sorry, too loud. My name is Angel. I work for the DevOps department here at Seek. I've been here for a year and a half. As most of my colleagues, obviously we are very familiar with PowerShell. We all of us have also a very good familiarity with Chef and Puppet. We all have Linux background as well, so we have a pretty good idea of what we want as infrastructure as code solution for Windows. So we did try Chef as the first priority to have our orchestration and infrastructure as code solution, and we found that it's like wrapping a banana, like as you can see here. It's the Chef seems to be designed for, let's say you already have Chef infrastructure, you already have a lot of Windows or a lot of Linux servers on the Chef, and you want to introduce Windows. It makes a little sense. It allows you to run in your recipe DSC script, and you can actually run a DSC script directly within Chef, or you can actually mimic DSC and translate directly the equals with columns and new lines with commas. And it doesn't work for us because we don't have Chef in our infrastructure. We have majority Windows, so this was like an overhead we didn't need. So we missed it completely. So what is DSC? DSC is PowerShell. It's a lot of singlet, commandlet functions that Microsoft has added to it. What it does, it basically creates small files. And these small files is a standard used by many other systems, and you're probably very familiar with this. It's literally you define a script with a state, which, well, you want this feature, I want this file, so I want this configuration. You apply that to your service, and your service will actually say, do I have this feature already? I do it. So I don't do anything. I don't have this feature, well, I install it, or vice versa. And there is two models very similar to Chef. You have a boot server, which will be equivalent to having a Windows, your nodes contacting the Chef server and say, well, which config do I need to apply? Which role do I have? Or you can apply scripts directly to them, like we'll be using Chef 0 or something like that. So all these PowerShell modules are, as they call, idempotentes. Sorry, I don't know how to say this in English. Idempotent text. So the point is, you define the state, you run the script, and you want always the same output you want. You want the script to take you to that state. So the functions are get target resource, test target resource, and set target resource, which is what every single PowerShell DSC's module will need to have, which is the fact that the part that checks what state you are in, and if you are not in it, you change it. I'm going to show you a real demonstration. Right, so in a very simple terms, a DSC script is a declaration of intentions, right? You basically say, oh, I want this feature to be installed in this server, and this server as well, because this is the common set of features. But in this other server, I just want this file. This is a very simple example. This is not the DSC script. This is only the configuration data, which is very handy to keep it separate from your script to make things simpler. And the DSC script looks like this. You will probably be familiar with this. You load the module. This is like which particular DSC module you want to load. This is actually come with Windows. It's not a custom module. It's all standard. And you basically say, I want you to install the features I gave you the configuration data and manipulate all the files I told you to do. So you can run this. This will be a push run, where you basically can see that my laptop has contacted these two servers and it has checked if the tenant features is installed or not. So you can see the destination object was found and no action is required. So this is DSC running in 2 seconds to say, well, I have nothing to do because I've done it already. And just to give you something, if you say absent over here, which is basically a very similar syntax to okay. Okay. So it's now doing the opposite for that particular Windows feature. It's now somewhere to say here, let's install it. Where is it? Okay. Successfully install the feature telnet client. So you run this a million times and it will always get the same output. So this is for you to get an idea of what DSC looks like. Go back to here. Right, so in order to put this into practice into a real application of setting up production service in our company, we define a series of steps and we use a series of tools. And we basically reuse the tools we're already using. So, Bootstrap, this is part of every part of infrastructure as code, right? You need to create a new server. Here is the network, here is the IP, username, and password, these basic things. We use Stash as source control. We use TeamCity as a build agent. This is like Jenkins or any other similar tool. Is the one that checks how I don't change something in the code. I need to do some tests. This is a NuGet repository. We use it to keep track of all our custom modules. Octopus Deploy is the tool we use to deploy already for code. And this is the full server. This I was playing more detail what this is what this provides you, the centralized point of your scripts. The point here is that we use the same pipeline that we use for code. So the Bootstrap is simple. We basically use packets to build machines in either VMware or AWS. It's a very simple Bootstrap. We just configure a very basic code image with just defining the hardware, username and password, and allowing them to connect with, this is the WinRM, is the current of SSH in Windows. And we install this latest version of PowerShell 5, which is by default is PowerShell 4. We want number 5 because it's very interesting features. Nothing rocket science in source code. Everything is file-based. That's the whole point of this. Is not having to manually do anything. Everything is in the code. We have custom modules. We organize in folders called DSC resources. We define in our files what are the configuration data, very similar to the configuration data you saw earlier, but obviously more complicated. Every time you change something, you do a commit in the master branch, this thing will trigger and it will do some tests. Again, this expected framework is very good. It mimics and mocks the results of everything you run. And if it succeeds, you have this very fancy Slack notification. It will tell to our chatting channel that something changed and everything is good. If it fails, there's somewhere there to blame, which is correct. And then you publish the changes to our package manager, which is this one over here. We use Procket. We could use any other thing like Artifact or anything. And this is the part where it says, okay, if everything is good, you publish that module to your repository, you have a new version. This feature of find module, install module, comes with OpenML5. That's one of the reasons we upgrade to it, because it gives us a lot of flexibility. Last but not least, Octopus and our existing deployment tool. This is where we define how our environments are different for staging production, what is the release numbers, who deploy what and when. And this is the pool server, which this is the new feature of the whole pipeline compared to code. It's changed, the mob file created with all that pipeline before, and you basically create mob files. These are the files that the pool server gives to the nodes. And the nodes just say, okay, I need this file. Sorry, I need this file, and just run it, and the local configuration manager in Windows will do all the work. So, in conclusion, we are benefiting a lot from the fact that we can reuse all the existing tools. DSC is a core functionality of PowerShell. It's not like like Puppet or Shell that have a server. They do everything for you. We use the existing tools to build our code. But they basically got us to create new service in production in 8 minutes, which is amazing. And there is no human intervention, so there is no human error. And there's still obviously a lot of areas of improvement that the DSC needs, in particular with reporting and error detection. And so when something fails, you need to look at the logs. It's slightly manual. But we're very confident that it's the best solution for Windows. It comes out of the box and all the reasons that James mentioned. And basically that is the details. You have questions, please feel free to go. Yes, please.
Hello. You had Octopus pre-existing as a tool technology you had before the DSC?
Correct, yes.
Okay, so I was curious about the decision to use Octopus to deploy, where no DSC can actually deploy and configure as well. So you install that feature of copy the files. You're still looking to use Octopus. Can you tell me about that decision?
So Octopus gives us the flexibility to make different deployments to staging, development, production, and have the ability to say which version we're in staging, which is the result of it, and can we promote that version to production.
Okay. So it's the release.
It's the release management.
Approval stage capability rather than just the deployment.
Correct.
Okay.
Correct. Give us that visibility that DSC doesn't have. Okay. You're welcome. Yes, please.
How do you manage your configuration data? Let's say Puppet has hierarchy, Chef has attributes. What do you do about shared secrets and that kind of stuff?
Good question. That configuration file you saw earlier, but it had oh, yes. So you can define roles in your code. You can basically structure your configuration data in many different ways. We have at the moment a file that represents the staging, a file that represents production. If you want to see it with different from the two environments, you need to compare the two files. We've done it in a way that the only difference you will find are the difference that makes sense to you, like different domain, different certificates, different IPs, and so on.
So how do you handle passwords? Yeah, like how do you handle sensitive data?
Sensitive data, Octopus uses that. Octopus allows us to save the passwords variables within Octopus, and then those variables that pass encrypted and passed to the configuration data. It's not visible to anybody unless you have the right permissions to see. No problem. Thanks. More questions? Yeah.
We're using DISM. Some of those things. Have you had experience with that and compare it with what you're using?
No, sorry. Which is the name of the model again?
DISM.
Not sure. No, sorry. I don't think we have used it. Maybe James, who is sadly not here, has done a lot of work regarding this. Maybe knows, but not sure. No.
You mentioned about Chef and Puppet.
Yes.
Have you looked at Ansible for Windows?
We did, yes. We had in one of the last hackathons, we actually got a good team of people trying DSC by itself, Chef, Puppet, and Ansible. We did try Ansible, and we found that was the less capable of dealing with PowerShell. Actually, we found that the installation itself, the server had to be Ansible tower had to be in Linux. Once you configure it, you had to install a module to connect to WinRM, which didn't even work. We actually had to hack the code to compile properly. It was like a very bad start, and we didn't see it. It was not impossible, but Chef and Puppet did that much better. Yes, please.
In one of your earlier slides, you mentioned that you brought down the time to create a, say, dev laptop, and you're aiming for like 2 hours.
Yes.
We've got a similar sort of problem, and we've been playing around with like the likes of Chocolatey, and you obviously referenced OneGet as well. So how have you got about that with regards to deploying applications to like your dev laptop in like a nice, easy, quick, efficient manner?
We have an image for the developers which has most of things already installed,
Okay.
which speeds up the process a lot.
Yeah.
PowerShell actually use Chocolatey, so we use DSC calls Chocolatey to install things on it as well. That by itself works pretty quick. So I'm not sure that answers your question.
So the question is, how do we install on a dev machine and do we use packaging? So what we do is we try and identify as much as possible that we can put on the baseline. And that's really important. So we just get that image up really fast. And what we're using DSC for is then applying all your application-specific stuff on your dev machine. Devs here at Seek like Seek in a box. They like everything on the dev machine. And typically they don't use VMs as well. They load it right on the machine. And so we use DSC for building up those images beyond that. But also there's certain things that don't really fit naturally on a baseline. So we've extended kind of a lot of what we do with DSC as well into changing registry settings, setting up SQL Server, running what we call germinating internally, which is seeding the SQL Server. And all that's kind of done in DSC. So there's still quite a few manual bits and pieces and steps, and that's why it's 8 hours rather than 2. But we're trying iteratively to get that down. But baselining is a really important aspect. What you can baseline it, absolutely. But what you can't feed from DSC. Does that answer your question?
That's great.
Perfect.
Any more questions? Thank you.
So next up we have Clarence, right? Yes. He's going to talk about Prometheus. Clarence has set up his laptop, so quickly. I'm going to get another drink.
Have a good day. I hate to go early as the big guy. Maybe that's what I did. Thank God it's he's just like neither the other guys that you got. How you doing? Hey, good look, man. Either just cool. Oh, yeah, I see that. That's amazing. That's from TV. Oh my goodness.
All right, we're good to go. All right, so this is Clarence. He's going to be talking about Prometheus. It's probably our first monitoring talk in a while. Clarence.
Hi everyone, this is my first time at Infracoders. There's a little bit of a hashtag fail. There's a little bit of a hashtag fail on my part. I imagine there'll probably be about 15 people. So I'm not sure if the hands-on demo format is the best approach, but I'll do my best. But I do have slides, sort of slides to fall back on.
I'm playing the part of a mic stand.
I can sort of talk to this part. I'll talk to this part, but so there's a little bit of slideware, and then I'll jump into the hands-on demo. So I'm going to be talking about Prometheus, which is a pretty cool open source monitoring system, which was developed at SoundCloud. It's been around since about 2012. Created by some awesome guys. I haven't met them, but they must be awesome because they open sourced it. And they sort of publicly announced this monitoring solution earlier this year. So what I'm going to show you, I haven't actually tried this in production. So don't go on Monday or tomorrow, don't go to your workplace and try this out just yet, although all the code's on GitHub. So what's different about Prometheus? Well, you might have heard say something like Nagios or Graphite, and all these sort of tools do different things, but Prometheus is an attempt to be like an all-in-one solution. So it does everything. It's a bit rough around the edges in some parts, but it's getting better. And most of it's written in Golang. So some of the interesting features are that it's a data model. It's pretty cool. If you've used OpenTSDB, it uses a similar approach where you have a metric and then you have a number of tags and labels that you can filter on. So this is pretty cool. If you use Graphier, you might have had to name all your metrics like something dot something dot something. It's very specific. Here you just use a very generic name and then you can filter down. So I'll show you that in the demo. It's got alerting. You can do ad hoc expressions. Use a pool-based system, so it will scrape metrics from any endpoint that you've set up. And let's jump quickly to the architecture before we go into the demo. So Prometheus server, being written in Golang, is essentially one binary that you run. So it's very easy to deploy. And it's completely standalone. There's no clustering or anything like that, though you can run multiple instances. Essentially, you point it at a bunch of endpoints, HTTP endpoints that expose a standard /metrics endpoint. It will scrape metrics from those endpoints. And if you've got short-lived jobs, like maybe cron jobs or batch tasks that aren't there all the time for Prometheus to scrape, you can use this thing called the push gateway. So your jobs will then push metrics to this gateway that's always running, and then Prometheus will periodically scrape those metrics. And then the other pieces of the puzzle are the prom dash, which is the dashboard where you can show some nice graphs. And lastly, the alert manager is basically the router. When there's alerts that are raised, the alert manager will send those through to PagerDuty or WebEdge's email or Pager or something like that. So in the demo, I'm going to be using Prometheus from Docker containers, Docker images, because it's pretty easy to do that. So I'm going to skip all this blah blah stuff. And let's go straight into the demo. Demo. That's sort of like the backup in case things don't work. All right, I think it's here we go. So it's quite scripted. Yeah. So a bit slow the alt tab. So what I've done is I've got a Docker Swarm cluster. So there's 2 VMs running, and here I'm on the terminal for the master, the manager node. So just to show you that there are things actually running here. So let's just show what's running. Swarm PS. So so you can see there's a couple of containers running, and it will tell you which server. So if it says prom server, that's the main server, and then there's a second server called server 2.
You should at the top of the screen.
Oh, okay. Yep. Is that better? Or
You're going.
Control-L and run it again.
yeah. Is that better? Okay. So let's run our application. So I'm going to run an application which uses 2 services, and it's going to be 4 instances of each service. So you can see here we've got the shop application, which I'll show you, and then we've got 4 instances of a catalog and 4 instances of a review service, and they're distributed across the 2 servers. So if we quickly jump over here and hit localhost 80. So we've got this application here, and it's dependent on some services. If you stop those services, this application will stop working. So now I'm going to start the monitoring containers, which is Prometheus and all its components. So now we've got Prometheus, the alert manager, the dashboard, and that's all running there now. So while that's there, let's continue. So we've got everything up and running. I'm trying to remember now. So there's the shop application. So as a side thing, I'll just show you. So Sorry, it's very slow to alt tab for some reason. So all of my containers are running in registering with console. So console is used by the application for service discovery. So if you're using container-based applications and you're using a cluster, you don't really want to care which specific hosts your containers are running on, but you need a way for your applications to be able to find those. So I'm using console. So if you look in console, you'll see that I've got this review service, the shop application, and it will tell you like how many instances are. So you can see there's 4 instances currently running. So later on, what I'm going to do is start killing these instances, and then hopefully you should see like an alert being raised. Sorry, back here. So let's just have a quick look at Prometheus, what it looks like, and then we'll go into the alerting part. So Prometheus has its own simple kind of front end. So it doesn't look very flashy, but it will tell you like the configuration it's set up with. So how frequently you should scrape all the targets, the alerting rules, so what it should do if a service goes down. And here are the targets. So currently I've got it scraping console, so it's going to pull metrics from console so it can discover all our services, and it's also going to pull more metrics from this thing called the container exporter. So Prometheus has the concept of exporters, so you can run as many of these as you want anywhere you like, and they export additional metrics. So this is pretty cool if you don't want all your applications to expose their own metrics. You can use exporters that will pull metrics from your applications for you. Yep, so everything's cool, the services are up. I'll explain later why there's separation between the health warning and is down. You can see the review service is up, the catalog and the shop app's up. If you go over to this graph tab, you can do ad hoc querying of your metrics. So for example, for containers, we might say we want to know what's the memory usage of our containers. So if you execute that, you get a whole bunch of stuff. But then you can also click on graph and you can see, you know, what's that look like as a graph. So this is the memory usage of all the running containers in the cluster. Now I might not care about, you know, like for example, I could do something like, you know, sum that. So what's the total memory usage? Sorry. So you've got all these functions. You can say, what's the total memory usage? Okay, what's that in, you know, megabytes or something like that. So it's got pretty flexible querying language. So what if we don't care about all these containers? There's so many of them here. So let's filter it down. Let's say that we only care about the review service. So you use this syntax where you can say, you can pick a tag. So you can see here, there's all these tags listed the metric name. So what I care about is the name. So I'm going to say where name matches something that looks like review service, because they're numbered like review 1, 2, 3, 4, etc. So now I can see just the 4 review containers and how much memory they're using. Now that's a bit hard to read, so I could actually do something like sum by, let's say I only want to show the name and maybe which machine it's running on. So this is kind of like SQL, we can do group by. So you can see now, I can see which machine they're running on, and I can see the name of the service. So I'll just leave it at that. We can do quite a lot of things. You can aggregate your metrics, but the cool thing is you just pick a metric and then you can start filtering it down and using functions to aggregate, do averages and sliding windows and all sorts of things like that. Okay, so that's memory usage for those 4 containers. So skip all that. Just because it's going to be very tedious, I'll sort of skip over some of this stuff. But I talked about you can do sliding windows, so you can say, you know, average over the time. You can do things like how much has the memory gone up or down in a particular period. So let's say, for example, this will give me like the instantaneous metric. But what if I want to know like what's it like over the last minute or over the last 30 seconds? So you can actually specify a filter at the end, like a range. Maybe. So here, I can actually see all the samples. So that was the value at that unique CPOC time. That was the sample at that time. So you got all the samples there for all of your metrics, and you can filter and aggregate them, and you can do average over time, etc. So skip that. Now, in the interest of time, let's just set up a dashboard quickly, and then we'll start killing some containers and hopefully see some alerts come through. Obviously, this stuff doesn't, when you're doing a live demo, it doesn't work out the way you imagined in your head. So I'm sort of skipping through some stuff, but if there's something you're interested in, come and see me afterwards. And like I said, all this stuff's on GitHub, and I can provide you a link to this document. Okay, so let's go to the dashboard. So it should be running on localhost 9093, please. Sorry, 3000 is a Rails app. There we go. So first of all, you have to create a directory. Just call it directory is just a grouping of dashboards, because you might want to have dashboards for a particular purpose group somewhere. And let's create a dashboard. We'll call it Infracoders. Okay. And then we need to also, set up a server. So from Bridges server, the URL where Bridges exists. Okay, so now we've got, it's pretty bare. What do we want to see? Let's say we want to see the memory usage on here. So for example, I could add a graph that says, let's see if I can cheat and get this. So I want to see the memory usage for all of the review. So they're all the review instances over time. So I could say I want that over a time range of 15 minutes or say 5 minutes. And I want this to refresh every 30 seconds. Notice I'm pressing save a lot because I always forget to do that and I'll lose all the changes. So you can actually, you can do things like full screen. You can actually get rid of all this stuff up here if you like, but I'll leave it there. You can get permalinks to it. So if you want to send, what did that look like at that particular time? Or you could do something like, I like this graph. Let's say I want to get a link to that graph, and I can send that link to someone else, and they can embed that in their own dashboard. So I thought that's a pretty cool feature. Another thing you can do is you can add frames. So let's say, hope that's the right URL. No, sorry. Let's say I want to that's one. So let's say I want to see the alerts on here as well, so I can do that. All right, so now I'm going to start killing some containers. So I'm going to kill review number 1. So if you look here, so I've got review 234 left. Go back here. Everything's going to be happy. I can tell you, I've set it up so basically if it's less than 2, let's go down to, we'll leave 1. So it's 3, let's kill 4. So now there's only 1 instance of the review service, but the shop application doesn't care. As long as it can find something in console when it does its service discovery, it's happy. Do that. Did I? Yeah. Yay! All right. Well, let's let's start that one back up again. So that's got paged. Yeah. So you can see here, review service health warning. I've set this up if the number of instances drops below 2 or less, we get this warning. And if the review service is completely nuked, like I just did, then this will become red eventually. So I've got this, just to show this is happening now. When that fires, we should get a notification, assuming you've got internet. Yep. So you should let me know. There we go. Review service health warning just came through. Only one healthy review instance is left, right? So that's red. Now the shop app is still healthy, but if we kill the last one, was it 4? So we killed 4. Just to speed things up again. So the shop app should say it's unhealthy because it needs the review service. So while we're waiting for that, there are better dashboards. You can use this Grafana, which is sort of a more polished dashboard that hooks into things like Graphite and InfluxDB. There's sort of experimental functionality for Prometheus at the moment via plugin. So I can show you what that looks like quickly. So that's kind of what I was trying to do, show how many instances there are left and all that, but we'll skip that. This is what PromDash looks like. This is what Grafana looks like. So it's a bit more polished. So if you're interested, you can try that one out. So when alerts are firing, they'll appear in the alert manager, and then you can do things like silence those alerts. So let's say you're looking into that and you don't want people to keep getting paged. You can silence an alert and then put a message in like I'm looking into that. As you can see, the alert manager is the most experimental part of Prometheus. So the core servo is pretty solid. Alert manager's got a big warning label saying it's experimental. You can see it doesn't look the best, but it will. But as you can see, the integration with like Slack and other applications is pretty good. And the PromDash component is reasonable. It's not the prettiest, but yeah, it does its job. So Shop app is now unhealthy. Cool. So let's see if there's anything else before sort of wrap up the demo. As you can see, there's tons of stuff in here. This will easily be like an hour talk, but I think I've shown you enough to get an appreciation of what you can do. So just before I wrap up, so if there's anything else I want to highlight. So the approach I've used in this demo is I'm using, rather than Prometheus actually knowing about all of my individual services, I've hard-coded some servers, there's 2 servers, but I'm actually using console and the console exporter to export metrics about all the services that are registered with console. So Prometheus indirectly finds out about all the containers through the console exporter. Another way you can do it is if you don't want to use console exporter, Prometheus supports service discovery of your node. So it supports DNS SRV records, or you can also use console as well directly. If you configure Prometheus that way, it will actually discover all your services directly. However, there's a bit of a trade-off. Let's say you had 10,000 services, it will actually go and scrape, 10,000 services. If you use console and you get console to get all the metrics via health checks, console is distributed in your cluster, so hopefully the load will be distributed, and then you'll be scraping essentially one endpoint to get those metrics. So it just depends whether you want lots of little scrapes or one big scrape. So this is all part of my own learning. I haven't used this in production, but I've been playing around with like what's the best way to monitor large clusters of containers without having to worry about which server or which port things are running on. I found it's working quite well. As I said, there's a few rough edges here and there. I think yeah, that's about it. Are there any questions around this? Was it good? Did it suck? So this is on GitHub. The Evernote that I was using, I can provide a link to that and share it if people are interested to follow through themselves and try it out. You just need Vagrant and VirtualBox, and the rest should just work. So any questions?
Grafana as a plugin for
Yeah.
So does it have what's its plugin like? Is it in?
Yeah, so that's part of Grafana. Not so Prometheus have written a plugin, and they've provided it to. It's on GitHub under Grafana plugins. It's essentially just a tarball that you extract into a directory where you've got Grafana installed. I think there's a containerized version of it as well. So it's not actually part of Prometheus. It's just a plugin that would so that Grafana knows how to query a Prometheus server. Because Prometheus provides metrics in a certain format. So it's kind of work in progress, but it works. Anything else? Has anyone tried anything like this? Have you got better at approaches? Or?
Oh, I tried it when it came out, and although it's, as you say, like I didn't think it was ready for alerting or anything like that, and it's more complex than the systems you're monitoring generally. Awesome alternative to graphite and how disgusting a lot of that is. And it like your talk looks like it's got lots of great detail in it, and definitely suited to like a really long, like a good long depthy talk. But I can safely assure that just to get it up and running and have a play and throw some metrics at it, it doesn't take long. It's not it's not complicated to do the basics. So.
Yeah, if you don't want to set up, graphite and Sensu and all these different things, and then using InfluxDB, you got to do the clustering. Everything like Prometheus is very simple. It's probably the easiest thing I've used. It does everything. And some bits are still, as I said, a bit rough around the edges, but it's very easy to work with. And I think the best part for me is the metrics and the querying. Just how you can sort of drill down and do aggregation. It's really easy to understand. I think I've looked at graphite a couple of times and kind of got confused about how it works.
So what's how's the data stored? Is it all in the metrics themselves? Are they flat files or in some sort of database?
I think it's flat files. I kind of peeked a little bit in the directory, but essentially just it's essentially append only. So every time you send out a metric, depending on the labels you provide with that metric name, a new time series is created. So if I add a new host name on that, as a tag on that metric, even though it's the same metric name, a new time series gets created, and then every sample just gets appended to that. So I think every metric has a separate file. So every time series has a separate file.
So my next question is, have you tried it with a month's worth of data somewhere and been able to use it? Because to me it sounds like those files would grow very big very quickly, and then finding things within them would be the next challenge. So how does it perform when you've got a month or 3 months or 6 months worth of data and you want to show what happened to Tuesday last week?
Yeah.
Is that something
That's
you've
a
tried
good
yet?
question. I wish I had a good answer. So I think I said earlier that I haven't used this in production, and the longest I've used it is probably like an hour running. But
running for a month.
I'm assuming, if someone can correct me if I'm wrong, I'm assuming like a lot of these, for example, like Graphite has like a round robin database where we'll purge old data. So I'm assuming there's a setting somewhere where you could say hold on to data for this period of time. But I'm not actually sure how. Like, I don't think we'll just keep those metrics forever. I know if you stop reporting metrics, like let's say if I remove one of my services from console, so there's nothing there to be scraped anymore, after 5 minutes, Prometheus just assumes that metric's dead, and it will just drop it after a while. I think you can configure how long it will hold on to it, but I don't know how purging and the round robin stuff works. I assume it's there. That's a good point.
From memory, you can set expiry per analytic as well, so you can say that this isn't that valuable after a day or so, and like your really high resolution stuff can stay there. And also, from memory, also the files that it creates are really really great for file system level compression. So if you're using like LZO compression or something on your file system, it massively compresses really nicely in memory. I actually tried it. I worked with George. I just asked a question. I tried it there, and I DOSed it by throwing shitloads of data at it over an hour or something like that, and I couldn't tell the difference in performance in the front end query anyway.
So yeah, where I'd probably like to try this out is maybe like on the Kubernetes cluster or something like that, and see how that goes. But yeah, I haven't actually used it in large scale, but hopefully it scales up. But if people have other ideas, feel free to shoot me a tweet or something, or an email, or send me a pull request or something, and we can fix it up. Maybe just before I conclude, because I think I've run out of time, I'll just show you my scroll. There we go. If you want to send me a message or something, or you want to make some improvements. Yep.
We're using the SVG stacks, that's the Grafana stuff, doing a lot of application metrics and monitoring on that. Is it possible to send some of that application metrics through Prometheus as well, or is it just the specific statistics that it picks up from?
Yeah, so one thing I'm not sure if that answers your question, but I did neglect to mention that you don't have to use just exporters. There are Prometheus client libraries that you can use in Java and .NET and whatever. They will actually provide scrapable endpoints in Prometheus format. They're also converters, so I think you can convert from graphite format or statsd format, whatever. It's like there's different converters you can convert between them. But if you don't want, so with this approach, the other reason I took this approach is I wanted something that's unintrusive, or is it non-intrusive or unintrusive? Yeah, where I didn't want to have to change my app. So this metric stuff was added on top of what, so the apps don't know anything about the metrics. There's exporters that export the container metrics, and console, I forgot to mention there's a thing called registrator. So registrator is the magic glue that puts your containers into console without you having to worry about knowing where console is. The apps know nothing and the services know nothing about console. So registrator is registering them, and the console exporter is providing that to Prometheus. So they're completely decoupled, and it's an unintrusive method.
We're using also to track business metrics and stuff like that, so we want those sort of metrics over time as well. But yeah, so you use those libraries that then put some information.
Yeah. Yes, there's counters, gauges, histograms. I think I've probably, it's nearly a half hour, so just one last question. Yep. Yeah, there's not really, but there's a nice page on Prometheus where they compare it to InfluxDB and Graphite. It seems like its model is closest to OpenTSDB. Graphite, I think, is a bit more limited. You know, the name all your metrics very specific, like HTTP requests, you know, .500 for 500 error code. I think there's ways you can use string manipulation to kind of aggregate, but I find this model's a lot nicer for doing that kind of aggregation and drilling up and down through the metrics. True, but I like to live on the edge. And one last thing is Graphite and InfluxDB, and they're really like passive. They expect you to push metrics, so they don't know anything about your environment. Whereas Prometheus knows about your environment, and it will scrape metrics, and it has a whole kitchen sink basically to do everything, which could be bad as well. So the creator sees an advantage that it's standalone. So you could actually, for redundancy, you can actually have multiple Prometheus servers scraping the same endpoints. So if one dies, the other one will have a copy of all the metrics. Yeah, there could be some skew on those metrics, not going to be exactly identical. The other way is you partition up your environment, so you have multiple Prometheus servers. So you might have one for production, one for, I don't know, pre-production, one for whatever. So that's how you would scale it. So it's a very simple model. They didn't, if you read their blog, like SoundCloud blog, they complain about the other tools not really suiting their needs, and they wanted something very simple. It definitely is simple. There's some metrics that definitely can support quite a large number of hosts on one server. It's like 2,000. But like I said, most of this is just how things would work. I haven't used it in production yet, but yeah. If anyone's interested in setting it up, one more. Last one.
Another question, but I think when used for Prometheus interactions, memory usage is really high over time. So myself, I got one that after mutants you just choose and I see a few people have the schema issues on GitHub as well.
Okay. So you're saying that Prometheus memory usage over time is like a leak and it gets bigger and bigger, like a Java app? How long ago was this? I mean, again, I haven't run it long enough to pick up on that, but perhaps it's been fixed. Like, was it recently?
It hasn't been really fixed. Some people like they've got instance have 64 gigs memory, but still.
Okay. It's possible. It's very fast to restart Prometheus, and you won't really lose metrics because it scrapes, right? You're not pushing to it. So if you restart Prometheus, let's say like, it's not the best practice, let's say you restart it daily, you're not going to lose any metrics.
Like a Java app?
One because Prometheus being written in Golang, it's like, super fast to start up, right? And it's a Docker container as well, the way I'm running it. So if you didn't restart it, you're not going to lose anything because it's a scrape model. So the metrics will still be there for you to scrape. So it's probably not a big deal, but otherwise I'd look in the code and submit a pull request and try to fix it. Yeah. All right, I think that's it.
So we have a third talk. Is Martin in the room? Just while Martin's getting set up. Can I do a quick poll? I love doing polls. Who's the first time at Infracoders tonight? Wow, so many. Matt and I really love feedback, so if maybe at least some of you come up to us and say, this was a really good meetup or a really crap meetup, or topics were at the wrong level or not interesting. Yeah, we really like that feedback. Too much Docker. Not enough Docker? About 2 minutes, get a drink, and drink some food. And then we'll have the third talk for tonight.
That's why I'm saying I said
All right, folks, so if you can grab your seats, we'll kick off the third talk, and there'll be plenty of time for discussion. Okay, grab a seat. Now we've got our third talk for tonight, which is Docker Introduction by Martin Booth. And after this talk, we'll do a quick community announcements section where people can get up and talk about any jobs they may have on offer, or if they're looking for jobs, they can also talk about themselves, and we'd like to connect people up in that way. But I'll hand over to our first speaker.
Thanks very much. Hi everyone, my name is Martin Booth and I work at Seek, and today I'm going to be talking a little bit about how we're running Docker in production. This is a talk which I did for a conference DDD, and I've cut this down, so I've really just decided to focus on one particular aspect of running Docker in production, and that is the build pipeline. And I do apologize in advance, I didn't really think about the height of the screen, so there will be a couple of commands which I run towards the bottom, so you might have to stand up if you want to see what they are. And so what I'm going to do is I'm going to talk about the journey that I took with getting some builds happening with Docker. I'll start off, so we're obviously Windows, as you guys know, we have a bit of Windows. We're going to move throughout this journey onto Linux and things, but I'll start from the beginning, and if you guys are just kind of Linux experts, you might want to skip over the first bit, but I reckon I'll have something which might be of interest somewhat through the presentation. So I want to start off with what our build looks like in Windows before we went on this journey. And so what it was a build server with a bunch of prerequisites installed in a bit of a snowflake manner. So we had some DevOps installed, .NET, Node, and Ruby, and Node's server was exactly the same as the other one. It's quite tough to get them all these prerequisites installed. We had a build written in PowerShell, And these were the steps that we had inside the build. It was clean, compile, test, create NuGet package, because we were using Octopus deploy, like mentioned earlier, and push to a NuGet feed. And so in order to go on this journey and try and get Docker a viable solution for us, we needed to go and swap out these very last two steps, create a NuGet package and push to NuGet feed. We're going to change that. We're going to create a Docker container, push that to a Docker registry. There we go. That's gone. And these are the new steps. So I'm not going to go into a huge amount of detail into exactly how that happens, because you can easily find online exactly what a build might look like on Docker. So I'm just going to walk through, what the next steps are if you've actually got a Docker build. So this was the easiest way we could actually get our application pushed up to Docker. I had a couple of problems. I'll start off by showing you how we did that. That is our original PowerShell build, which we had written in PowerShell. And what I'm going to do now is I'm going to swap out that package step in NuGet and replace it with a Docker build command. And I'm also going to take out the publish step, which is unfortunately towards the bottom, and replace that with a Docker push. And this, if you want to get from a Windows environment Docker up and running, is all that you actually really need to do. As long as you've got a Docker file in place, you can actually turn your typical Windows build, which produces NuGet artifacts, and turn it into a Docker container. So that is the build happening in PowerShell with those commands in place. And now I'm just running Docker up there. You can see the build has gone pretty well. And I can load up the website, which is in fact what the build is. It's a running a container. And it's a cat in a container. We put everything in containers, including cats. So back to my slide. This is great if you just want to do the minimum you possibly can to get your build running in Windows. But it does introduce a bit of an issue. And that is that we now need a Linux virtual machine to actually make it happen. Add that into an already quite packed build server. The thing is with Docker, as you guys probably know, it only runs in Linux. So if you're going to do your build on Windows, which you have to if you've chosen PowerShell, because that only runs on Windows, then you end up in this situation. You need two operating systems running at exactly the same time, just to build a basic application, which all it does is put a cat in a container. So it's a bit of a pain in the ass. So the next step, if you're coming on this journey with me, is to try and get rid of one of those dependencies. At the moment, we cannot run Docker on Windows. That's something that's in the pipeline. So if we're going to eliminate one of those operating systems, it's going to have to be Windows. Yay! So the next step is out with the PowerShell build and in with something which is at least able to run on Linux. So we can't really chuck out all of our .NET code in C straight away. So teams out there that want to, and I might be one of those people who are quite happy to see the back of it. But for now, we have to use, we have to get the old code running. So we've got F#fake, which is actually a way we can write our builds in a .NET compatible way. It can run on top of Mono, and we've actually introduced the penguin at the top there, just to show that our Windows builds can still take place. It will run on Windows, so for those who do still want to stick to their favorite operating system, it can still happen. But it'll also run on Linux. And that actually means we can get rid of the virtual machine. You can just run it at least on one operating system. So that's a great improvement. However, we can go better than this, because after having got to this point, we're pretty happy with where we are. We've got Docker building,